This is Mrs. Haslauer's video on finding side lengths of overlapping triangles. What you need to know by the end of the video is how to set up an appropriate proportion. It's using the same skills that you learned yesterday with working with your similar figures, and how to break apart overlapping triangles. That part is going to be optional, but I highly recommend it. So take out your note sheet and let's get started for today. Overlapping triangles are formed when you have an original triangle. Like, for example, this one down here, RQS is just a plain old big triangle. Try to forget that this line is here. So you take a regular triangle and then a parallel line, a line that has the same exact slope to one of the sides of the triangle, cuts through the other two sides. All right, and when that second parallel line cuts through, in this case it's RT, it cuts the two sides of the triangle proportionally, which makes one triangle now into two similar triangles, the big triangle and then the smaller one up at top. And because the parallel lines cut it the other two sides of your triangle proportionally, we can find missing side lengths and do all sorts of work with it. So here's an example right here of how you would work with your now similar triangles. The most common is to think of it as the side over the whole is equal to a side over a whole. Where did I come up with the 7? Well, I looked at the side, which was RT, which is this just the side length of 3, and I'm comparing that to the proportion of 7, which is the larger of the same side. All right, where did I get the 7? All you do is add the 3 and the 4 and you get your 7. And the same thing is true for this side of your triangle. 6, which is the smaller of triangle RUT, this guy over here, over the 14, which is the side of the bigger triangle, which was 6 plus 8. And then you would reduce and make sure that they're in proportion, and you do get 3 over 7 is equal to 3 over 7. Now this one, I already gave all your side lengths. The one below it is asking you to find a side length. So the best way to understand it is just to practice it yourself. With a little bit of practice, guys, it's really not that bad. It's just getting used to the pictures. So let's get started. You do need to understand how to read your notation. It's really not that bad. You've seen most of the symbols by now. So in our example, it says given QS. So you just follow the letters QS. We're talking about this segment right here. Is parallel, that's what those double lines mean, to UT right here. So you also already know that they are parallel because of these little arrows here. Again, we've talked about this, that the arrows do mean parallel. That's important. They're there for a reason. Because these two lines are parallel, that means that RT and RQ have been cut proportionally. So I do have two similar triangles. They're just overlapping each other, one on top of the other. They then give you measurements. They tell you that ST, so you just follow the letters. ST is 6, it's already labeled for you. QU is 9, and we want to find the length of RQ. So that's this segment here. Since we don't know what it is, we're going to label it with a variable. We already know that. Whenever we don't know something in math, we use our variable to represent that number. Now, the only way to figure out the side length is to use proportions to understand that these two triangles are definitely similar. And whenever you have similar triangles, it means that you can set them equal with your proportions. But there are right ways to set up your proportions and wrong. For some of you, I'm sure you've already started and you don't think that this is all that difficult. For others, if you have a difficult time looking at the picture and seeing two triangles, I recommend that you redraw it and you just split it apart, guys. Start by redrawing the main triangle, RUT. So it doesn't have to be perfect. You don't need to get out a ruler or anything like that. All you're going to do is try your best to recreate the main triangle. You're going to label it to keep track of what side is what. And I want you to label it with the side lengths. UR is the whole length of the triangle. So what that is R plus whatever that other side length is. I know it makes a binomial, 9 plus x, but everybody should know that those are not like terms, so you're just going to leave it 9 plus x. No overcomplicating it. The right side is a little bit easier because you know both side lengths, and you get 4 plus 6, which is 10. So here's my main triangle. I don't know what the base is, but that is not important. I don't need it. The other triangle is formed by the parallel line. So it's RQS. It's this guy right here. If it's hard for you to see it, you're just going to redraw it on your paper. You're going to label it. It's Q, R, S. This guy right here. It's your note sheet. You can write all over it, whatever you need to do to make sense of it. So what's the length of QR? That was X, and the length of RS is 4. Again, you don't know the base, but that's okay. You can only ever compare two sides at a time with your proportion. So now we're all set. You can completely forget about the overlapping triangles up there if you redrew it down here. And now hopefully you see it and you think it's a lot easier. So when I go to set up my proportion, there's quite a few ways to set it up. As long as you're getting the same cross products, you'll be okay. But if you're not getting the same cross products as I am, then your proportion is wrong. So how I'm going to do this is I'm going to say the left side of this triangle, 9 plus x, is to the left side of this triangle, which is just x, is equal to 10 to 4. Now there's other ways to set it up. This is how I'm going to do it. You can also have x plus 9. Remember that addition is commutative. And now I have two fractions set equal. Whenever I have two fractions set equal, everybody knows we're going to cross multiply. So we're going to do x times 10, or 10 times x, is equal to 4 times 9 plus x. Remember that 9 plus x is a binomial. It needs to be in parentheses. This has to be distribution. You're not just multiplying the 4 by the 9. You then have to go and multiply the 4 by the x. Very common mistake. Please do not do that. So here's our rainbow math, our distribution. 4 times 9 is 36. Then you have to go back out and grab the superhero. Comes back in to get the x, and you get plus 4x. Now there's variables on both sides, so we're going to set up our v's on the left and our c's on the right. 10x is a variable, so he's okay right there. I'm going to subtract my 4x. Since he's not a constant, he's a variable. He belongs on the left side. 10x minus 4x is 6x equals 36. There's 0. The 6 and the x are connected by multiplication. I'm going to break them by dividing, my inverse operation, and 36 divided by 6 is just 6. There's your value for x. So every time you see an x, you're going to plug in a 6. So let's go back up to our work. We want the length of RQ. So let's make sure that we answer our question. RQ, let's find it, is right here. The length of RQ is represented by just the variable x. We figured out that the variable x represents the number 6. So we're all set. There's our answer. But let's go one step further. Not only do we now know RQ, but we can also figure out RU, which was the length of the bigger triangle. What we would do there is take our binomial 9 plus x, substitute the 6 in for x, and you get a length of 15. Now, I know the question didn't ask for that, but I wanted you to understand that you can always go a step further. All right, so break your triangles apart. I think it's a lot easier. That's what I would recommend that you do. And then you can just see your two similar triangles next to each other instead of overlapping. So let's flip it over and let's try the one on the back. Remember that you can pause me, and if you want to try this one on your own, take advantage of the fact that this is recorded. So here's our triangle. All right, they give you very, very, very little information. All right, the triangles are already labeled for you, and they have these arrows here. You need to pay attention to the arrows. They're important because they're telling you that this line DC, the line segment DC, is parallel to the segment EB. If they're not parallel, you don't know for sure if they're similar, so be careful with that. We want to find the length of AB. You just follow the letters. AB is right here. Now it's up to you. You can set up your proportion with your similar triangles as is, or you can separate the triangles from one triangle to two. I usually start with the bigger just because I think it's easier to see. Completely up to you. I am not doing any math right now. All I'm doing is redrawing my main picture. So this is D, C, A. There's my triangle. I need my side lengths. Well, DA is not 12, it's not 14, it's 12 plus 14. It's both the segments added together, which gives you 26. Over here, you're going to get your binomial, x plus 18. 18 plus x would be fine also. The commutative property allows you to switch your order around. Now, you don't know anything about this side of your triangle, but that's okay. You only need 2. Split up your smaller triangle. Again, it doesn't have to be perfect. You don't need a straight edge or anything like that. This is triangle EBA. EA is 14, AB is X. And now you've got everything you need to set up your proportion. We're looking for X. Lots of ways to set it up. As long as your cross products are the same as mine, then you set it up correctly. 26 of this triangle is to 14, as X plus 18 is to X. 2 fractions set equal, we're going to cross multiply. 26x equals 14 times x plus 18. Again, in parentheses, make sure you're going to distribute. Very common mistake. We don't want that to happen. 14x plus 14 times 18 is 252. Now again, we got variables on both sides. If you need to set up your fence, you can. You've got 26x on one side and 14x on the other. Variables on the left, constants on the right. It's not the only way to do it, but it's the best way, I think. We want to avoid negatives if we can. 14x and 252, 14x, that's a variable. It does not belong there. There is a positive on the 14. The way you move a positive 14x is by subtracting 14x. Inverse operations. 26 minus 14, positives win by 12. Don't forget the x, it's still in the x family, equals 252. The 12 and the x are connected by multiplication. You want to break it by division. X equals, do not reach for a calculator. We have to know how to do our long division. The numerator belongs inside the nice house. It goes inside. 12 into 25 is twice. 12 times 2 is 24. Subtract 1. Drop the 2 down. 12 into 12 is 1, and you get a remainder of 0. So it actually just ends up the whole number, 21. Every time you see an x, you plug in a 21. Okay, well, I got a 21 here, and I've got a 21 here. So the length of AB is now 21. So that answers my original question. But on top of the AB, you can also find AC, which is 21 plus 18, which gives you 39. So it really is up to you. You can either keep the picture the same and work at it that way, or you can split them up. I know your triangles won't be as perfect as mine because I have the use of the computer, but as long as your pictures are organized, they're labeled, and you put the measurements in the correct place, you should be fine. It's up to you. If you have any questions, please let me know.